video for Chapter 5 is going to talk about forces, systems, and inertia. Okay, so first off, force. What exactly is a force? So forces are important because forces are really the central idea in Newtonian mechanics. If you don't understand forces, you're not going to understand Newtonian mechanics. So a force is really just a push or a pull. And of course, a force is a vector quantity because it matters if you're pushing to the left or if you're pushing to the right or if you're pushing up or if you're pushing down. Those are all different. So forces very naturally have a direction associated with them. So they're a vector. The other important thing to remember is that forces always come from interactions between objects. So if you're going to have a force, you actually need to have two different objects. So one way to think about it, and this is the terminology the textbook uses, so you can think about the source of the force, which is where the force comes from, and the subject, which is what the force is pushing or pulling on. And you can divide these forces into two types. So first off, contact forces. So contact forces are forces that require the two objects to physically touch each other. So let's say I push on the wall. So I'm physically in contact with the wall and I'm exerting a force on the wall. Well, and it turns out the wall is also exerting a force on me, but we'll talk about that when we get to Newton's third law. So contact forces require the two objects to touch. Field, or sometimes called non-contact forces, don't require physical contact, and they can act through empty space. So if you've ever played with magnets, right? So magnets, if depending on how you align up the poles, they either repel each other or attract each other, and they don't need to be physically touching. So the magnetic force is an example of one of these field or non-contact forces. Okay, so the other important thing here is a system. So the force, remember, was always resulted from an interaction between two objects. So we're going to define something called a system, which is just a collection of two or more objects. So it could be 2, it could be 3, it could be 127. So, how we define our systems is going to become important, because it actually has to do with how you define forces. So we're going to call an internal force is something that has a source that is part of the system. So if the source of the force is inside the system, then by definition this is an internal force. And an external force has a source that's outside the system. So this is actually going to be important how you then define your system, because whether a force is internal or external depends on how you define your system. So this is a picture from the textbook, right? So you can imagine, we've got a person standing on a scale inside an elevator, and there's different ways we can define the system. We could think about the person only, we can think about the person and the scale, we can think about the person and the scale and the elevator all together. And whether these forces are going to be internal or external depend on how we define the system, right? And remember, back to Newton's first law, that Newton's first law actually talked about these external forces, right? In order to change an object's motion, you needed an external force. All right, so one more thing to talk about here. So inertia. So inertia is the tendency of an object to resist changes in its motion. So, for example, if you think about a ping pong ball, well, it's very easy to change the motion of a ping pong ball, so a ping pong ball has a small amount of inertia. However, a freight train has a lot of inertia, right? Because it's very difficult to change the motion of a freight train. So, inertial mass, or usually we just call this mass, is actually the measure of how much inertia an object has. So the SI unit of inertial mass is the kilogram. So it's actually not the gram. The kilogram is the official SI unit. And also the US customary unit, and I know engineers love to use these US customary units, the unit of mass is actually called the slug. So, and the other important thing, we'll talk more about this later, but mass is different than weight. So they are not the same thing. And